Hello everyone, I'm Ruolan from Tsinghua University. It's my pleasure to share our work, MindShift, leveraging large language models for mental state-based problematic smartphone use intervention. Problematic smartphone usage has become pervasive, especially among young adults, which may affect the user's efficiency, physical well-being, and even mental health. Current interventions can be summarized into four categories based on their degree of enforcement. First, feedback, which means giving people details about how they use their phones, such as visualization, like the screen time on the iOS system. Second, reminders, which help people think twice about using their phone by sending them pop-up messages. Third, interaction friction, which makes using the phone more difficult, like making people tap something to continue using it. Lastly, logout, which completely stops people from using their phone for a certain time, like the Forest app does. However, there are a few gaps. First, existing methods are hard to strike a balance between good usability and effectiveness. In our work, instead of using logout mechanisms, we employed reminder intimation techniques to ensure usability. Rather than using a rigid template such as merely notifying the time usage, we boosted intervention effectiveness through contextualized and personalized persuasion. Second, while some current interventions use context-based strategies, like triggering interventions at specific times and locations, they tend to focus mainly on external physical contexts, overlooking internal mental factors, which are increasingly recognized as one key factor leading to problematic smartphone use. We believe that a more holistic approach, considering both the physical and mental context, could enhance intervention effectiveness. To address these gaps, we developed MindShift. MindShift considers the user's usage behavior, physical context, and mental states. Moreover, we also design persuasion strategies along with users' goals and habits. Then use large language models to generate dynamic, personalized, appropriate persuasion messages. To understand the mental states of users' smartphone use and guide our intervention system design, we initiate a Wizard of Oz study. The Wizard of Study used a chatbot on smartphones to monitor app usage and discourage usage with human-crafted messages, alongside daily interviews about user experience. Following this, a semi-structured interview study was conducted to explore users' mental states further. We summarize four main takeaways from these two studies. First, interventions should target habitual usage. Our study distinguished between habitual use, which is automatic, and instrumental use, which is purposeful. Among these, we find relaxation to be a form of instrumental use, which shouldn't be intervened either. Second, the effectiveness of interventions depends on the alignment with users' mental states, personal goals, and contextual information. Third, there are three primary mental states behind habitual use. Burden is the feeling of being unengaged and dissatisfied due to insufficient stimulation. Stress is the mental response to unpredictable and unmanageable challenges. Inertia is the psychological resistance that makes users not want to change their current activity state. Last, we observe two subcategories of mental states based on activity engagement, leading to 6 categories of habitual smartphone use. For users engaging in activities, persuasion also encourages them to either continue or initiate their activities. Based on the takeaways, we propose persuasion strategies. According to the dual systems theory, there is a competitive relationship between System 1, which represents habitual smartphone use, and System 2, which represents meaningful activity, much like being placed on a scale. To make System 2 heavier than System 1, weights should be added. The ERG theory summarizes human motivation into 3 levels. First, existence, which represents basic needs. Second, relatedness, which represents social needs. And third, growth, which represents self-actualization. To support relatedness needs, we designed two persuasion strategies, understanding and comforting. To motivate growth needs, we designed two other persuasion strategies, evoking and scaffolding habits. We map four strategies to three mental states. Understanding aims to express empathy and covers all mental states as a coping mechanism. Comforting aims to comfort users who are experiencing emotional fluctuations. For burden, it focuses on meaningfulness. For stress, it uses encouragement, humor, and wishful thinking. For inertia, without explicit negative emotions, is not employed. Evoking means invoking users' personal goals. This strategy is applied only to scenarios where users are engaging in activities. Goals are arguments used to encourage them to complete or initiate their tasks. Scaffolding habits means encouraging users to develop alternative beneficial habits. It covers all mental states. Now I will introduce the design of our intervention system. Initially, we explored what content to intervene with. We used a test case to show how context and mental states affect content creation. We employed GPT 3.5 to create four sets of messages, differing by context and mental state considerations, finding both enhanced content quality. Contextual data enables GPT to customize outputs for the user's situation, while mental state guidance helps manage negative emotions, such as incorporating empathy. We design LLM input prompts through an iterative process, crafting a template with slots for physical context, including time and place, usage behavior, including duration and frequency, user mental state, goals, habits, and our persuasion strategies. The prompt includes first, test setup, second, current context description, third, prompt optimization for better quality and safety, and fourth, persuasion strategy description. Then, LLM generates persuasion content with different strategies. Here are a few examples of the content. The interaction process consists of four steps. Users first complete two global settings. The first is to set their values, detailing their goals for the evoking strategies and their habits in the scaffolding habits strategy. The second is to set a blacklist of apps. When opening a blacklisted app, users need to first self-report their intent. Only when the user's intent is habitual, the intervention will continue, and users need to report their current mental state. After that, a corresponding persuasion shows up. Users can provide optional feedback by giving a thumbs up or down, and they can choose to either quit the app or continue using it. Furthermore, for the scaffolding habit strategy, it's essential to link users' own habits to specific use context. Therefore, we implement a user participation mechanism, adding an additional habit item along with an edit button. The same habit will be recommended the next time when users are in the same context. We devised a simple procedure to loop over persuasion strategies. After determining the mental state, we will loop over all strategies under this mental state every 2 minutes until the users leave the app. We compared MindShift with two techniques. Baseline only uses an intent report, and MindShift Simple removes mental state-based persuasion strategies. Baseline can be treated as a traditional reminder intervention technique. MindShift Simple can show the power of LLM, while MindShift can show the impact of incorporating mental states further. We adopt a within-subject design, with intervention techniques as independent variables. We evaluate MindShift with 25 users through a 5-week field experiment. The first week is set as the baseline stage, followed by 2 weeks of one MindShift version and another 2 weeks of the other version. We counterbalance the order of MindShift Simple and MindShift. Results show that MindShift improves overall intervention acceptance rate by 4.7 to 22.5%. Compared to MindShift Simple, MindShift significantly outperformed on the persuasion acceptance rate by 8.1%. At the same time, MindShift outperformed on a per-round basis by 6 to 14.7%, which proves our persuasion strategies effective. Moreover, MindShift has the highest sum-up rates. MindShift and MindShift Simple reduce the overall opening frequency and usage duration. Moreover, after using two versions of MindShift, users have a significant drop in smartphone addiction scores and a rise in self-efficacy scores, while the baseline does not. This suggests that MindShift has the potential to profoundly transform human behavior with enduring effects. Our approach, MindShift, contrasts with traditional time-based intervention techniques. Instead of quantification usage metrics, we focus on the purpose of phone use and the mental states of users. We aim to intervene in habitual smartphone use triggered by specific mental states and help individuals transition from avoidance coping to approach coping. Looking ahead, we plan to enhance our interventions for greater personalization by integrating user feedbacks and to automate the self-report of users' intent and mental states using machine learning and additional sensors. Additionally, we explore the potential of using large language models for behavior change, noting their ability to influence user behavior. We discuss the design implications for applying LLMs across other domains, emphasizing the need for understanding user behaviors, contextual sensitivity, and effective prompt crafting. However, we also recognize some considerations associated with the safety of generated content, privacy issues, and the risk of increasing user stress, highlighting the need for further research. To summarize, first, we identified three major mental states behind problematic smartphone use and designed four persuasion strategies. Second, we created MindShift, which leveraged an LLM to generate dynamic and personalized persuasion content based on user context. Third, we show the effectiveness of our system through a real-world deployment experiment. Thanks for your attention, and I'm happy to answer any questions.